But it cuts both ways because Jupiter has no value system. When it sees an errant comet, it may attract it and swallow it up, but where it flings it is anyone's guess, and so errant comets can be flung in towards Earth, they can be flung into the sun, and they can be flung out of the solar system.
There's a reason the planet rejects some of the space junk heading its way.
Jupiter, being the biggest object in the solar system, has the most gravity. And so other objects, little fleas that have their own trajectory flying by, are bent from where it would be towards Jupiter, and usually with an acceleration. And that acceleration can cause it sometimes to just be ejected completely.
No earthly frisbee thrower can match Jupiter's flinging force. It is much faster than any bullet ever known. It rejects things at a rate of 30 miles per second. Jupiter's wonders are hard to fathom. They've captivated man for centuries.
Prehistoric humans realized that it was moving among the stars, and it was one of the planets that they appreciated. And Jupiter was the king of the gods, after all, in Roman mythology.
And there may be a biblical reference to Jupiter.
Ever since I was like 5 years old, I remember people, oh, that was the Star of Bethlehem. And whether or not it really was, obviously we have no way of knowing. But it's not clear whether the star that was talked about is a single star or whether they meant an astronomical alignment of objects in the sky. We don't really know.
It's known as conjunction in scientific terms. According to researchers, Jupiter and Venus did appear as one large star-like object in August 3 BC and would have been visible in the eastern night sky. But it was Galileo, the father of modern astronomy, who made the first recorded sighting of the Jupiter system.
In the early days of 1610, only about 18 months after the telescope was invented, he got his own telescope and he looked at Jupiter.
In 1665, Jupiter's most fascinating feature was discovered. Its giant red eye was actually the eye of an enormous storm, unlike any experienced on Earth. This one has raged for at least 300 years. This weather disturbance is a meteorologist's dream.
Jupiter's Great Red Spot is truly huge. You could take Earth and fillet it out and it wouldn't even really cover the spot.
This storm is the hugest storm in the solar system. Just to give you a feeling about it, it's about 12,000 miles. And the Earth is only 8,000 miles wide.
And the winds blow quite fast around the edge, but it's calm in the center. It's not like a hurricane, which has an eye and very fast, turbulent winds in the center. The red spot is rather calm. If you were in a balloon, it might be a pleasant ride, as long as you avoided the small-scale stuff like the thunderstorms and the turbulent places. Even though you'd be going very fast, it might be quite calm.
Fast as in 350 miles an hour. The fastest wind ever recorded here on Earth was 175 miles an hour. But is it an Earth-like storm?
It's a giant collection of clouds roiling around, lightning going on. So we can only model and imagine what kind of precipitation, but condensation in the form of condensed vapor of various gases.
This famous red spot is a high-pressure system that can take 10 days to complete a rotation.
It's really a backwards hurricane. It's called an anticyclone. That's the name for it. So it goes backwards from the direction of a typical hurricane.
That's not the only curious thing. Hurricanes as we know them need water in order to form. there's no water engine in the red spot. This never-ending weather system is feeding on something else. But what? Jupiter's Great Red Spot is something like a non-stop hurricane. It's a colossal storm, complete with violent wind and lightning. Storm chasers would love to go running after it. Dr. Tim Dowling of the University of Louisville is in the hunt for similar phenomena here on Earth.
The red spot is, think of it as a huge extra lens or egg shape of mass. It's just an enormous thing. It sort of quiets down the fluid. It presses it down into the hotter interior so you don't get thunderstorms. But if you go on the edge of the red spot, especially northwest, you get some of the most horrific thunderstorms you're going to find on the Jupiter.
The spot doesn't have an eye, and it isn't fueled by water. There's no ocean over which it forms. What then keeps it going and going?
I've always likened it, in my own view, as like a mini volcano inside of Jupiter.
Actually, an atmospheric volcano. Dr. Baines believes that warmer gases rise from heat deep within the planet. While trying to escape, they create a vortex.
So, for some reason, I believe there's extra energy right there.
But it's just a theory. Science is left without answers to that question and others. Current theories cannot quite explain why the spot is so well formed and why it stays in one place. The plot thickened over the years as scientists learned even more.
It became a deeper mystery because instead of everything just sort of smoothly going around the red spot, we saw this turbulence, and there were smaller scale structures that would come and go every day, and it was chaotic and turbulent, and yet the red spot just existed and sailed on.
Jupiter's storms aren't limited to the Great Red Spot. Cloud decks 3 layers thick hover and cover the planet.
If you were inside the atmosphere of Jupiter, you would hear very loud thunder. In fact, the thunder actually travels 4 times faster on Jupiter than it does on Earth. It's about 3,000 miles an hour. So rain falls twice as fast on Jupiter. The charge separation that pulls the positive charge to the top of the clouds, the negative charge to the bottom of the clouds, is twice as efficient on Jupiter for that reason alone, because the rain is falling so much faster. Towers of cumulus convection that you see on Jupiter are 3 times taller. They go up 30 miles, whereas on Earth they go up 6 or 7 miles.
It would be impossible to survive within the Great Red Spot with its 350-mile-an-hour winds. By comparison, Hurricane Wilma, which had the highest recorded winds of any earthly storm, slammed into the Yucatan Peninsula in 2005 with barely a breath. 175-mile-an-hour blasts. Our weather is simple. Jupiter's is complex.
Now on Jupiter, you just basically have one storm system sort of stacked on another, with lots and lots of room. Basically, these are the storms in their natural state.